Bismillahirrahmanirrahim. Assalamu alaikum dear students. Hope so that you all are fine. Today is our lecture number 3 from chapter number 1. And the topics which we have discussed in previous lecture, they include volume of gases, percentage composition, excess and limiting reactants, and numerical problems related to all these topics. I hope that you have attempted these numerical problems. And the topics which we will cover in today's lecture, they include theoretical, actual and percentage yield, numerical problems related to these topics, and exercise will also be discussed in today's lecture. First, starting with the theoretical, actual and percent yield. Theoretical yield is the amount of the product which we can calculate by the balanced chemical equation. And the actual yield is the amount of the product which we will obtain by the experiment when the reaction takes place. So we can define both the theoretical yield and actual yield in this way, that the maximum amount of the product calculated using balanced equation, and the actual yield is the amount of the product obtained when the reaction takes place. And the last one we have percent yield. The ratio of this actual yield to theoretical yield is called as percent yield. We can calculate the percent yield with the help of this formula, that the percent yield is equals to actual yield divided by theoretical yield multiplied by 100. In this way we can calculate this thing, that how much the amount of the product which we can obtain for a particular reaction. The next one we have efficiency of reactions. There are many reactions for which the actual yield is almost equal to the theoretical yield. Such reactions are quantitative. But on the other hand, for some reactions, particularly those involving the organic compounds, the actual yield of reaction is less than the theoretical yield, and percent yield is less than 100%. This is because the reaction may not go to the completion and may reduce the yield of the product, or some material may be lost during the handling. So the actual yield, it may be less than the theoretical yield due to the different reasons, and we have compiled the reasons. The first reason is that side reactions may produce byproducts, that along with the desired reaction, some side reactions are also occurring with the particular reaction, so the amount of the desired product will be less in that case. And the second reason we have that some reactions are reversible reaction. So reversible reaction, they never goes to the completion, so we are not getting the amount of the exact product. So the actual yield will be less in this case also. And the last one we have that the amount of the product may be lost during the mechanical handling processes. Like for example, it can be lost during filtration, distillation, either separation by separating funnel or different methods, or it may be lost during washing or crystallization process. So these are the different reasons that the actual yield may be less than the theoretical yield. Now we have a sample problem related to this topic. In an industry, copper metal was prepared by the following reaction, and the balanced chemical equation we have that the zinc reacts with copper sulfate, we will have the formation of zinc sulfate plus copper. 1.274 gram copper sulfate when reacted with excess of zinc metal, we will get 0.392 gram of copper metal. Calculate the percentage yield. Now in this reaction, the balanced chemical equation is also given to us, and we are provided with two things. One is the mass of copper sulfate, which is 1.274 grams, and the other thing which we have, the actual yield of the copper. They didn't mention this thing that this is the actual yield, but in statement it's visible that this process is actually taking place in industry and it yields a 0.392 gram of copper. So this one will be your actual yield. What we have to calculate the percentage yield. For solving this numerical problem, as the copper sulfate is given in grams, so first we have to convert the quantity of this copper sulfate into moles. According to the reaction, we have 1 mole of zinc. It reacts with 1 mole of copper sulfate. We will have the formation of 1 mole of zinc sulfate plus 1 mole of copper. And the given mass of the copper sulfate, we have 1.274 grams. And the molecular mass of the copper sulfate, if we calculate, it comes out to be 159.6 grams per mole. We can also use the simple formula for the calculation of the number of moles, that which we have used for a lot many reactions, that the number of moles is equal to given mass divided by the molecular mass. You can also use that formula, or you can also use this relationship, that 159.6 grams of copper sulfate is equal to 1 mole. So if we have 1.274 gram of copper sulfate, it will be equal to 1 divided by 159.6 multiplied by 1.274. So the moles of the copper sulfate, we have 7.982 into 10 raised to power minus 3. And the next step, we have to calculate the theoretical yield of the copper with the help of the number of moles of copper sulfate. As we are provided with two things, one the copper sulfate, which is reactant, and the other one we have to calculate, it is the product, copper. So stoichiometrically, if we just look at the balanced chemical equation, we can say this thing, that the 1 mole of the copper sulfate, it gives us 1 mole of copper. So if we have 7.98 into 10 raised to power minus 3 moles of the copper sulfate, so it will gives us 7.982 into 10 raised to power minus 3 moles of copper. So in this way we can get the moles of the copper. So using these moles of the copper, we can calculate the mass of the copper matter, which we can obtain theoretically from this reaction. So the atomic mass of this copper, we have that the 1 mole of copper is equivalent to 63.5 gram. So we can calculate the mass of the copper with the help of this formula, that the atomic mass multiplied by number of moles, we can get the mass of the copper, which is equals to 0.5072 grams of copper. And this one is the theoretical yield. Now we have both the actual yield and theoretical yield. Theoretical yield is equals to 0.5072 grams and actual yield is equals to 0.392 gram. We have calculated this from the balanced chemical equation, and actual yield is given to us in the statement of this problem. So by using the formula that the percent yield is equals to actual yield divided by theoretical yield multiplied by 100. By putting both these quantities, grams, they cancel out with each other. So the percent yield for this reaction is equals to 77.3%. We have next sample problem, that in a reaction 2 moles of methane were reacted with an excess of chlorine. As a result, 177 grams of carbon tetrachloride is obtained. Balanced chemical equation is already given to us. What we have to calculate theoretical yield, actual yield and percent yield of reaction. In given data, we have moles of methane is equal to 2 moles and the mass of the carbon tetrachloride, which is equals to 177 grams. We have to calculate three things: theoretical yield of carbon tetrachloride, actual yield of carbon tetrachloride and percent yield. For solving this numerical problem, first we write the balanced chemical equation from the statement of this problem, that 1 mole of methane, it reacts with 4 moles of chlorine. We will have the formation of 1 mole of carbon tetrachloride plus 4 moles of HCl gas. So first we will calculate the theoretical yield. If you observe this thing, that in previous problem the quantity of the reactant is given in terms of grams. So that's why first we have converted those grams into moles. But here the reactant quantity is already given to us in terms of moles. So we have to proceed with these moles further. Stoichiometrically, if we look at the chemical equation, that the 1 mole of methane gives us 1 mole of carbon tetrachloride. If we have 2 moles of methane, so it means 2 moles of methane gives us 2 moles of carbon tetrachloride. So from these 2 moles of carbon tetrachloride, we can obtain the mass of carbon tetrachloride by multiplying the moles with the molecular mass of this carbon tetrachloride. So the mass of carbon tetrachloride is equals to 308 grams. This 308 grams will be the theoretical yield. Now the actual yield. As I read the statement of this problem, that as a result 177 grams of carbon tetrachloride is obtained. In the statement of this problem, they didn't mention this thing that this one is the actual yield, but this is the amount of the carbon tetrachloride which we are getting from the experiment. So this means that this 177 grams is the actual yield of this reaction. So now we have both the theoretical yield and actual yield. So for the calculation of the percent yield, we have to use the formula that actual yield divided by theoretical yield multiplied by 100. By putting the values, the grams they cancel out with each other, and after solving this, the percent yield of this reaction is equals to 57.46%. Related to this topic, we have a science tidbit given in your book. We have 2 questions in this and you have to attempt both of these. This is your home task. Now moving towards the exercise, we have the MCQs first. Select the most suitable answers in the following MCQs. For some of the MCQs, I have written the statement in the slides, while for some we have to read the statements from the book. The first one we have, how many molecules are there in 1 mole of water? We have discussed this thing that if we have 1 mole of any compound, so the number of molecules in it will be equivalent to the Avogadro's number. So the option B is the correct option because the option B value is equals to 6.023 into 10 raised to power 23. Number 2. A flask contains 500 cubic centimeter of sulfur dioxide at standard temperature pressure. The flask contains, now all the options they are given in terms of grams. It means you have to calculate the amount of the sulfur dioxide at standard temperature pressure in 500 cubic centimeter. 1 mole of gas at standard temperature pressure is equals to this much volume, and this volume is called as molar volume, 22.414 cubic decimeter. But as the volume in this statement is given in terms of cubic centimeter, so first we have to convert this cubic decimeter into cubic centimeter. So we will get that 22,414 cubic centimeter. So this 22414 cubic centimeter of sulfur dioxide at standard temperature pressure has a mass equivalent to 64 grams. This is the molar mass of this sulfur dioxide. So if we have 500 cubic centimeter of sulfur dioxide, so its mass will be 64 divided by 22414 multiplied by 500 is equals to 1.427 grams. So from all these 4 different options, we have this value in option D. So option D will be the correct option. Number 3. That a necklace has 6 grams of diamond in it. What are the number of atoms in it? So you have to use the number of atoms formula, which I have discussed in particles. That the number of atoms is equals to given mass divided by atomic mass multiplied by Avogadro's number. Mass is given to us 6 grams, and as we know, this diamond is the allotrope of the carbon. So This 12 gram is the atomic mass of the carbon. 6 gram divided by 12 gram multiplied by Avogadro's number. After solving this, the value which we will get is 3.01 into 10 raised to power 23. So the option D will be the correct option. The next one we have, what is the mass of aluminium in 204 grams of aluminium oxide, Al2O3? So for solving this, the molar mass of the aluminium oxide is equals to 102 grams per mole. This 102 grams per mole of aluminium oxide, it contains 54 grams of aluminium, as we have 2 moles of aluminium in this aluminium oxide. So if we have 204 grams of alumina, it contains how much aluminium? So stoichiometrically we will solve this thing, that 54 divided by 102 multiplied by 204, we will get the value 108 grams of aluminium. So the option D will be the correct option. The next one we have, the reactant which is consumed earlier and gives least quantity of product is called as. In options we have reactant in excess, stoichiometry, limiting reactant and stoichiometric amount. And I have explained in detail that the reactant which is consumed earlier and it gives the least quantity of product, it will be the limiting reactant. So the option C is the correct option. Sixth one we have, that which one of the following compounds contains the highest percentage by mass of nitrogen? We have 4 different options: ammonia, hydrazine, nitric oxide and ammonium hydroxide. This MCQs is basically related to the percentage composition. You have to calculate the percentage of nitrogen in all of these 4 different compounds. So using that formula, in ammonia you have to calculate the percentage of nitrogen, similarly in hydrazine, similarly in nitric oxide and ammonium hydroxide. Here we have only one atom of nitrogen, so this mass of nitrogen over here, it will be 14 divided by the molar mass of the compound, which is 17 multiplied by 100. So the percentage is equals to 82%. While the percentage of nitrogen in hydrazine, we have 2 atoms of nitrogen in this, so its mass of nitrogen in hydrazine is equals to 28 divided by the molar mass of hydrazine, which is 32 multiplied by 100. So the percentage of nitrogen in hydrazine is equals to 87%. Similarly, we have calculated the percentage of nitrogen in nitric oxide and ammonium hydroxide. So after solving this, we will get 46.6% and 40%. And in MCQs, they have demanded this thing, that which one of the compound is containing highest percentage by mass of nitrogen. So from the percentages, we can conclude this thing, that hydrazine, the option B, will be the correct option. Number 7. Vitamin A has a molecular formula C20H30O. The number of vitamin A molecules in 500 milligram of its capsule will be. The vitamin A molecular formula is given to you, which is C20H30O, but the mass of this is given in terms of milligrams. So first you have to convert these milligrams into grams. Milli is equals to 10 raised to power minus 3. So for converting the milligram into grams, you have to divide this 500 by 1000. So the given mass will be 0.5 grams, and the molar mass of this vitamin A is equals to 286 grams. So you can calculate the number of molecules with the help of the particle formula, that the number of molecules is equals to given mass divided by molar mass multiplied by Avogadro's number. After putting the values 0.5 grams divided by 286 grams multiplied by Avogadro's number, we will get the value 1.05 into 10 raised to power 21, which is given in option B. So the option B will be the correct option. The next one, 8th one, we have that when 1 mole of each of the following is completely burned in oxygen, which will give the largest mass of carbon dioxide. The options we have carbon monoxide, diamond, ethane and methane. For this, you have to write the chemical equation for the burning of these compounds in the presence of oxygen. I have written all the chemical equations. That the carbon monoxide, it reacts with the oxygen, we will have the formation of carbon dioxide. Diamond, it reacts with the oxygen, we will have the formation of 1 mole of carbon dioxide. What we have to calculate, that we have to calculate the largest mass of carbon dioxide from all of these reactants. If you look at these chemical equations, the largest mass of carbon dioxide we are getting in case of ethane. That 4 moles of carbon dioxide we are getting from this equation. So the option C will be the correct option. MCQ number 9. 1 mole of ethanol and 1 mole of ethane have equal what? In A option they have given mass, number of atoms, number of electrons or number of molecules. So the option D will be the correct option, that 1 mole of ethanol and 1 mole of ethane have an equal number of molecules. The 10th one. Methane reacts with steam to form hydrogen and carbon monoxide as shown below. The balanced chemical equation is given to us. That 1 mole of methane, it reacts with 1 mole of water, we will have the formation of 1 mole of carbon monoxide plus 3 moles of hydrogen. So what volume of hydrogen can be obtained from 100 cubic centimeter of methane at the standard temperature and pressure? From this equation, we can conclude this thing, that 1 mole of methane is equals to 3 moles of hydrogen. So if we have, and all these they are given in terms of gaseous state. So if we have 100 cubic centimeter of methane, so the 100 cubic centimeter, we multiply that 100 with 3. So this 3 multiplied by 100 cubic centimeter of hydrogen, we will get 300 cubic centimeter of hydrogen. So if 100 cubic centimeter of methane is there, it will produce 300 cubic centimeter of hydrogen. So the option A is the correct option. Next one we have that Avogadro's constant is the number of, in option A they have given this, atoms in 1 gram of helium, molecules in 35.5 grams of chloride, electrons needed to deposit 24 grams of magnesium, and option D they have given this thing, atoms in 24 grams of magnesium. So the option D is the correct option in this case, that atoms in 24 grams of magnesium. The 12th one we have that how many moles of oxygen are needed for the complete combustion of 2 moles of butane. So for this you have to write the chemical equation. The formula for butane we have C4H10 and it burns with the oxygen. So the butane, when it burns with the oxygen, we will have the formation of carbon dioxide plus water. After balancing this, you have to calculate the number of moles of oxygen needed for this reaction. And we have 13 moles of oxygen. So the option D will be the correct option, that the 13 moles of oxygen will be required for the complete combustion of 2 moles of butane. 13th one we have that if 4 moles of sulfur dioxide are oxidized to sulfur trioxide, so how many moles of oxygen molecules are required? And then again in this MCQ you have to write the balanced chemical equation. They have demanded this thing, that 4 moles of sulfur dioxide are given to us, so how many number of moles of oxygen will be required for the combustion of these 4 moles of sulfur dioxide? So after writing the balanced chemical equation, so the number of moles of oxygen which we need for its complete combustion, we have 2 moles of oxygen. So the option D will be the correct option, that 2 moles of oxygen are required for the complete oxidation of the sulfur dioxide to sulfur trioxide. 14th one we have that the relative atomic mass of chlorine is 35.5. What is the mass of 2 moles of chlorine gas? 1 mole of chlorine gas is equals to 35.5 into 2 is equal to 71 gram. This 35.5 is the atomic mass of chlorine, and chlorine gas we have this in the molecular form. So this 35.5 multiplied by 2 is equals to 71 grams. So if we have 2 moles, so 2 moles of chlorine gas will be equals to 71 multiplied by 2, we will have 142 grams of chlorine gas. So 142 gram is given in option A. So option A will be the correct option. 15th one. Which of the following statement is incorrect? In option A, they have given this thing that 12 gram of carbon gas contains 1 mole of atom. This is correct. 28 gram of nitrogen gas contains 1 mole of molecule of nitrogen. This is also correct. In option C, that 1 cubic decimeter of a 1 mole per cubic decimeter solution of NaCl contains 1 mole of chloride ions. This is also correct. So in option D, they have given this thing, none of above. So it means that all the options A, B, C, they are correct, while in the statement they have asked this thing, which one is incorrect. So the option D, we mark the option D that none of the above. The next one we have that 1 mole of propane has the same. In option A, they have given this thing, the number of hydrogen atoms as 1 mole of methane. No. In propane, we have C3H8 is the formula of propane. So A is not correct. In B, the number of carbon atoms as in 1 mole of butane. No. The number of carbon atoms in propane is 3, while in butane we have 4. Mass as a half a mole of hexane. It's also incorrect. In option D, we have that the number of molecules as in 1 mole of ethane. This one is correct. That we have discussed this thing that the 1 mole of any compound, it has equal number of molecules equivalent to Avogadro's number. The next one we have that what is the mass of 1 mole of iodine molecule? You have to calculate the mass of iodine molecule. The mass of iodine atom is equals to 127, while the mass of iodine molecule, simply multiply this 127 with 2, we will get 254 grams. So the option A will be the correct option. And the last one we have that what volume of sulfur dioxide at room temperature and pressure is produced on heating of zinc sulfide if reaction takes place as follow. The balanced chemical equation is given to us that 2 moles of zinc sulfide reacts with 3 moles of oxygen. We will have the formation of 2 moles of zinc oxide plus 2 moles of sulfur dioxide. We have to calculate the volume of this sulfur dioxide. And we are provided with the amount of zinc sulfide 9.7 grams. So first we will convert this grams of zinc sulfide into moles with the help of this formula that the moles of zinc sulfide is equal to given mass divided by molar mass. After putting the values, the moles of zinc sulfide will be equal to 0.1 mole. So stoichiometrically, from this balanced chemical equation, we can relate the zinc sulfide with sulfur dioxide. So from the balanced chemical equation, 2 moles of zinc sulfide gives us 2 moles of sulfur dioxide. So if we have 0.1 moles of zinc sulfide, it gives us 0.1 moles of sulfur dioxide. So 1 mole of sulfur dioxide is equals to its molar volume 22.414 cubic decimeter. So if we have 0.1 mole, so multiply the molar volume with the 0.1 mole. We will get 2.24 cubic decimeter. So the option B will be the correct option. In book they have mentioned this 2.4, but there should be this 2.24 cubic decimeter. So in this way, that's all about the MCQs from this exercise. Next one we have question number 2. Then answer the following questions briefly. The first one we have that 58.5 atomic mass unit are termed as formula mass and not molecular mass of sodium chloride. Why? As I have discussed during the lecture that whenever we have ionic compounds, so in case of ionic compounds, instead of molecular mass we use the term formula mass. So that's why the sum of the masses of the individual ions they make up the formula mass, and it consists of formula units. So the formula mass of sodium chloride is equals to 35.5 plus 23 is equal to 58.5 atomic mass unit. Second one we have the concept of limiting reactant is not applicable to the reversible reaction. Explain. As the reversible reactions they never goes to the completion, so the none of the reactant in them is consumed completely. So the concept of limiting reactant is not applicable to the reversible reactions. Third one we have how many covalent bonds are present in 9 grams of water. We are provided with the 9 grams of water. First you have to convert these 9 grams into moles with the help of this formula. So the number of moles of water we will have 0.5 moles. As we know this thing that the 1 mole of water molecule is equals to Avogadro's number of molecules. If we have 0.5 moles of water molecules, so multiply the Avogadro's number with the 0.5. So in this way we will get the molecules of water in 9 gram. 3.01 into 10 raised to power 23. And in one water molecule we have 2 covalent bonds. Here we have to calculate the number of the covalent bonds. So multiply these number of molecules with the covalent bonds. So 2 multiply 3.01 into 10 raised to power 23 will gives us the number of covalent bonds present in 9 grams of water molecules. Part 4. The differentiate between limiting and non-limiting reactant. We have explained in detail about the limiting. Non-limiting means excess reactant, reactant in excess. So we have defined this limiting reactant that the reactant that is consumed completely in a chemical reaction is called as limiting reactant, and the reactant which remains unused during a reaction is called as excess reactant. Limiting reactant, it controls the chemical reaction, while excess reactant, it doesn't control the chemical reaction. Part 5. That how many molecules of water are there in 12 grams of ice. You have to use the number of molecules formula in this. Now the number of molecules is equals to given mass divided by molar mass multiplied by Avogadro's number. That the 12 grams divided by 18 grams multiplied by Avogadro's number, we will get the molecules of water in 12 grams. That 4.02 into 10 raised to power 23 molecules of water. Part 6. That 1 mole of sulfuric acid should completely react with 2 moles of sodium hydroxide. How Avogadro's number helps to explain it. Reaction between acid and base is called as neutralization reaction, which produces salt and water as the product. And the balanced chemical reaction for this H2SO4, it reacts with 2 moles of sodium hydroxide. We will have the formation of sodium sulfate plus 2 moles of water molecule. According to Avogadro's number, if 1 mole of sulfuric acid, it contains Avogadro's number of molecules. So 1 mole of sulfuric acid, it releases 2 moles of hydrogen ions in solution in order to neutralize the base. If we write the splitting of sulfuric acid, so it will be like this, that sulfuric acid, it gives us 2 moles of hydrogen ions plus 1 mole of sulfate ions. So in order to neutralize these 2 hydrogen ions, we need 2 hydroxyl ions from the base for the complete neutralization. So 2 moles of this sodium hydroxide must be in the reaction for the complete neutralization of these 2 hydrogen ions. The next one we have part 7. Give reasons that 1 mole of different compounds have different masses but have the same number of molecules. We have discussed this thing in detail in Avogadro's number. That 1 mole of different substances having different masses but they contain the same number of molecules in them. That 1 mole of the substance has 6.023 into 10 raised to power 23 molecules in it. If we have different compounds, like for example, we have 17 gram of ammonia, 44 gram of carbon dioxide and 98 gram of sulfuric acid. They have the same number of molecules in each one of them. They have different masses, but they have the same number of molecules in them. Part 8. That the 23 grams of sodium and 238 gram of uranium have equal number of atoms in them. 23 grams of sodium is equals to 1 mole of sodium, while 238 gram of uranium is equals to 1 mole of uranium. So 1 mole of these 2 different compounds, they contain the same number of the atoms in them. According to the Avogadro's law, the 1 mole of each element contains 6.023 into 10 raised to power 23 atoms in them. Part 9. That we have to calculate the percentage composition of glucose and also we have to define the percentage composition. We have discussed the definition of percentage composition in detail. So regarding the calculation of percentage composition of glucose, first you have to calculate the molar mass of glucose. And the molar mass of glucose is equals to 180 grams. And we have 3 different elements in this glucose: carbon, hydrogen and oxygen. We have to separately calculate the percentages of these 3 different elements in glucose. And the percentage of carbon is equals to 40%, percentage of hydrogen is equals to 6.66%, while the percentage of oxygen is equals to 53.33%. Next we have part 10. To calculate the weight of oxygen gas evolved when 5 gram of potassium chlorate are completely decomposed thermally. The balanced chemical equation we have to write first, that upon the thermal decomposition of potassium chlorate, we will have the formation of potassium chloride plus oxygen. So 2 moles of potassium chlorate gives us 2 moles of potassium chloride plus 3 moles of oxygen. We are provided with the grams of potassium chlorate. So first we have to convert these grams into mole with the help of this formula. And here we have used the formula mass because this potassium chlorate is an ionic compound. So the number of moles of potassium chlorate is equals to 0.004 moles. So stoichiometrically we have to compare potassium chlorate with the oxygen. From the balanced chemical equation, if we look at this balanced chemical equation, 2 moles of potassium chlorate gives us 3 moles of oxygen. So if we have 0.004 moles of potassium chlorate, so how much amount of this oxygen we will get? So we will have 0.06 moles of oxygen from 0.04 moles of potassium chlorate. And 1 mole of oxygen is equals to 32 grams. So 0.06 moles of oxygen will be equals to 32 multiplied by 0.06 moles is equals to 1.92 grams. Right, there is one mistake, there will be 0.06. There are some parts in this question number 2 that in these parts we have discussed in details, that part number 11, 12, 13, 14, 15, 16. We have discussed all these during the lectures. And the last one we have that what is stoichiometry and stoichiometric amount. Also we have discussed this thing, that stoichiometry is the study of the relative amounts of different substances involved in a chemical reaction is called as stoichiometry. And the stoichiometric amounts, these are the amounts of the substances measured stoichiometrically during chemical reaction, are called as stoichiometric amount. Next we have question number 4, 3rd and 4. You have to solve these 3 and 4 as your home task of this lecture along with the science textbook questions. And question number 5 is already given to you girls during the previous home task. And question number 6. In question number 6, the part A is that how will you calculate the theoretical yield and percentage yield in balanced chemical equation? We have discussed this thing in detail. Regarding the part B of this question number 6, that a small piece of pure aluminium metal having a volume of 2.50 cubic centimeter is reacted with excess of HCl. What is the weight of hydrogen liberated? And the density of aluminium is 2.50 gram per cubic centimeter. We have provided with two things. One is the volume of aluminium and the density of aluminium. We have to calculate the mass of hydrogen liberated. First you have to write the balanced chemical equation for this reaction, because in the statement of this problem balanced chemical equation is not given to us. That 2 moles of aluminium when reacts with 6 moles of HCl, we will have the formation of 2 moles of aluminium chloride plus 3 moles of hydrogen. So in most of the numerical problems we are provided with the masses, but here there is slight difference, that we are provided with the volume and density. So by using the volume and density we have to calculate the mass of the aluminium. So we can calculate the mass of the aluminium with the help of this formula, that density is equal to mass by volume. So density of aluminium is equal to mass of aluminium divided by volume of aluminium. So mass of aluminium is equal to density multiplied by volume. So in this way the mass of aluminium is equal to 6.75 grams. Now from this gram of aluminium we have to convert this gram into number of moles with the help of the same formula. So the number of moles of aluminium we get is equals to 0.25 moles. So from the balanced chemical equation it is obvious that the 2 moles of aluminium gives us 3 moles of hydrogen. We have to compare aluminium and hydrogen. 2 moles of aluminium gives us 3 moles of hydrogen. So if we have 0.25 moles of aluminium, so how many moles of hydrogen will be obtained? So after calculating this, 0.25 moles of aluminium gives us 0.375 moles of hydrogen. Using these moles we can calculate the mass of hydrogen in grams, which is equals to 0.750 grams. Next we have question number 7, which I have already given to you girls in the home task of previous lecture. And the last one we have question number 8, that which contains more atoms, 1 mole of iron or 1 mole of hydrogen. Justify your stand. 1 mole of iron is equals to 6.023 into 10 raised to power 23 atoms of iron, as this iron is an element and hydrogen is a molecule. So 1 mole of hydrogen is equals to 6.023 into 10 raised to power 23 molecules of hydrogen. If we calculate the number of atoms in this, so we multiply the Avogadro's number with the 2. After multiplying this, we will get that 1.2 into 10 raised to power 24 atoms of hydrogen. So it means that 1 mole of hydrogen, it contains more atom as compared to 1 mole of iron. So that's all about from this chapter. We have discussed the chapter in detail, all the examples and also the exercise. If you have any problem related to this chapter, you can ask me in the WhatsApp group. Take good care of yourself. Allah Hafiz.